question says, what is the energy of a photon of light with a frequency of 8.84 times 10 to the 14 hertz, or seconds to the minus 1? So as discussed previously, if we know the frequency or the wavelength or the energy of a photon, we can calculate the other two. So if we know one of those three things, we can calculate the other two. This is because they're all related by constants. So in this case, we're given the frequency and we're asked for the energy. We could be asked for the wavelength, like in a previous question. So here we have E equals h nu. This is sometimes also written as E equals hc over lambda, depending if you're trying to relate energy and frequency or energy and wavelength. In this case, we want energy in joules, and this is the frequency in hertz, or seconds to the minus 1. H is something called Planck's constant, which is 6.626 times 10 to the minus 34 joule seconds. In this case, we want energy, we're given frequency, so we can just simply plug in. H again is a constant, Planck's constant, which is 6.626 times 10 to the minus 34 joule seconds, joules times seconds. Then we want to plug in the frequency in hertz, or seconds to the minus 1, which is 8.84 times 10 to the 14 hertz, or seconds to the minus 1. When you do that math, you find that the energy of this particular photon is 5.86 times 10 to the minus 19 joules. So a single photon has an incredibly small amount of energy, just like a single electron or proton has an incredibly small amount of mass. However, if you have lots of photons, you can transfer lots of energy, and that will be seen in a subsequent question.